Alright, sorry about that. Pause, the video messed up. The other thing that I want to show you that you can do with your graphing calculator, which is going to be a useful tool for you on this test as well as your EOC. There is a feature in here where I can put the points in and tell the calculator to graph it. So make sure as I'm doing this, you're going along with me. So we're working with our graphing calculator right now. If I want to put these in, I can hit this button that says Stat. So we hit Stat, Edit. Notice I've got two different lists. I can type all my X values in list 1, all my Y values in list 2. So my X values are 1, enter, 2, enter, 3, enter, and 4, enter. Then when I want to type the Y values, I can press the button on the right, 2, enter, 4, enter, 8, enter, and 16, enter. So once I've got all my points in there, I need to tell my calculator that I want it to plot these points. So if you notice, right above Y equals, it says Stat Plot. If you hit second, Y equals, hit enter, you're just going to cut it on. So that's all I'm doing. Second, Y equals, I'm going to that first one, so hit enter and make sure it's on. So I just went through that twice. If you didn't get it, we can pause, ask the substitute to pause the video, and y'all can make sure your group has it. So now that I've got that in there, I'm going to quit, clear my screen, and hit graph. Now you'll notice that you can see some of the points. If you want to make your calculator to where you can see everything and it zooms out so you can see it better, if you hit zoom and you scroll down, you'll notice where it says zoom stat. So zoom stat is saying that it's going to zoom specifically for the points you put in stat. So we're going to hit enter, and you'll notice that now I can see that that's forming an exponential growth function. So just like we did, either way, it's a good tool to have to quickly look and see what's going on. So let's go through it one more time just to make sure that we understand. So we're going to put in this second table into our stats. So we start off by going to Stat, Edit. Now notice my X values here are different. So I'm going to go back to change my X values to 2, 4, 6, and 8. Then I need to change my Y values. Those are 4, 8, 12, and 16. Once you have those in there, since I've already cut on the stat plot, I don't have to do that again. But just as a reminder, you would hit second Y equals, but since I see that it's on, I don't have to do anything there. So we're going to go ahead and graph it. I'm not seeing all my points, so we want to go to zoom and down to zoom stat, hit enter. So now that we see this, those points are forming a line. So that's going to be a linear function. So that one's not going to work. If you'll notice, each of these are increasing by 4. So that's a common difference. It's not a common ratio, which is what we need for exponential. So moving a little bit quicker, if we want to check this third one, we're going to go to Stat, Edit. Our X values are 3, 4, 5, and 6. our y values are 15, 12, 9, and 6. We can hit graph. I can see all the points, so I don't need to zoom, but I can see that that is linear. So, can't be that one. And if you notice, 15 to 12, I'm going to have to subtract 3. 12 to 9, subtract 3. And 9 to 6, subtract 3. So if I'm ever adding or subtracting, it's going to be linear, not exponential. And last one, either way you did it, if you started by looking to see a ratio versus a difference, here from 11 to 14, I would have to add 3. 14 to 17, add 3. 17 to 20, add 3. So this one should show me a linear graph. So just to be sure, let's check. 4, 5, 6, 7, 11, 14, 17, and 20. We hit graph. I'm not seeing all my points, so zoom stat. Hit enter, and we are seeing that line. So all 3 of these are giving me linear instead of exponential. Now remember, if there's anything you're confused about, put a star, circle the number, whatever, so that when you come in tomorrow, you can ask me questions about it and I can help you out before the test. So, if we look at number 2, it says which type of function best fits the data in the table below. Now let's say that you really don't remember how to use the stat function on your calculator. You could sketch out a graph and plot these points. So I'm going to make a graph that's got a big section for the first quadrant because all my values are positive. So my x values just have to go to 7. So 1, 2, 3, 4, 5, 6, 7. My y values have to go to 32. I'm going to try to do it by 2. So 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, 32. So I just kind of filled in some of the numbers to make it easier. And this is only if you don't remember how to use the stat function when you're taking your test. So if I wanted to go through, I could plot these points. I've got a point at 132. So I'm going to plot a point at 132. And obviously this is a sketch, so it's not going to be perfect. I've got a point at 310. So at 10, or 310, I'm going to have a point. At 5, 4. And at 7, 1. So from that, you can kind of see that it's forming an exponential function. So I know that linear is totally off the table. It's not going to be linear because it's not forming a straight line. Growth, remember, growth is going to go up from left to right, so that would be growth. Decay is going to go down from left to right. So this one is going to form a exponential decay model. If you had remembered on your calculator, and I'll move my calculator in just a second so you can look at that again, you could have used the stat function here. So I would put 1, 3, 5, 7, and 32, 10, 4, and 1. Graphed it, hit zoom stat, and you'll see that we're getting pretty much the same thing that we just sketched on our paper. You could do the same thing with these problems up here. It's whichever's easier for you, whichever is faster, whatever makes more sense. Once again, if you're confused, put a mark beside it. Now, for number 3, it says, for what positive integer value, so it's got to be a positive number, will the value of g of x equals 3 to the power of x first exceed? Now, exceed means that when is it going to be bigger than the value of f of x equals 2x plus 25? What we're going to do here is we are going to use the table on our graphing calculator. So I'm going to take g of x, and I'm going to let g of x be my y1. And this might make more sense when I start putting in the calculator. I'm going to let f of x be my y2. So what that means is I'm going into my y equals. I'm going into my y equals, and I'm going to type those functions. So here's why I said y1. y1 is the first function. I'm going to put g of x as my y1. So g of x equals 3 to the power of x. So 3 to the power of x. F of x is my y2, and f of x is 2x plus 25. So all I'm doing here is putting them in y1 and y2, and I want to look at the table. So remember, the table is second graph. So we're going to hit second graph, and I'm trying to find what value of x will make g of x bigger than f of x. So remember, g of x was our y1, f of x was our y2. So I'm going to scroll down until these numbers get bigger than this. So I'm going to keep going down. At 3, I've got 27 and 31, so it's not bigger yet. But at 4, notice I've got 81 and 33. So at 4, that's the first time that g of x was bigger than f of x. So that's my answer. So we just had to see where this number was bigger than this one, and it happened at 4. And we'll do a few more examples of this to make sure it makes sense. So looking at number 4, now I'm trying to figure out what's the smallest positive integer such that f of x equals negative x squared plus 5x exceeds g of x, which is negative 10x plus 10. It helps me, and I don't know if it's going to help you or not, it helps me to remind myself which one I'm going to make y1 and which one I'm going to make y2. Just so I've got that reference on my paper and I don't have to click back and forth. So we go back to y equals. I'm going to clear out y1, so hit clear, and I need to put in this function. So negative x squared plus 5x. Negative x squared plus 5x. My y2 this time is negative 10x, so negative 10x plus 10. Remember, once we have both those functions in there, we're going to hit second graph, and I'm trying to see when f of x is bigger than g of x. So I'm going to scroll until I see that this value is bigger than this value. Well, if you notice, I've got 4, which is bigger than 0, so that happens at 1. Number 5 is just like 3 and 4, so I want you to do that one as a practice. But go ahead to the right side of your paper, and we are going to look at number 6. So number 6, I've got my two functions. F of x equals 20 plus 50x, and g of x equals 50 times 1.5 to the power of x. So it says, which statement is true about the two functions when x equals 10? This one, you could put it in the table if you wanted to, or you could just plug the numbers in. Either way, I'm going to plug the numbers in because I think it's going to be faster. So we've got 200 plus 50 times 10. I'm putting 10 wherever I see x. So 200 plus 50 times 10. That gives me 700. Do the same thing for the other one. So I've got 50 times 1.5 to the power of 10. So 50 times 1.5 to the power of 10. And I get 2,883.25. I'm just going to round to 2 decimal places. So I just need to say which one of these is true. So the value of f of x exceeds the value of g of x by 50. So is the value of f of x bigger than g of x by 50? F of x is smaller, so that's not going to be true. So I can eliminate all the ones that say f of x exceeds g of x because g of x is bigger. Now, B says the value of g of x exceeds the value of f of x by about 50. If I go back and I subtract these, if I say 2,883.25 minus 700, I still got about 2,200 left. So it's obviously not going to be by 50, but it is going to exceed by about 2,200. All right, and last but not least, number 7, two functions are shown below. F of x equals 1.02x plus 100, and g of x equals 50 times 1.02 to the power of x. So once again, I'm trying to find which number makes g of x exceed f of x. So I'm going to say that f of x is my y1, g of x is my y2. So go into our calculator. We go to y equals. I'm going to clear it out. My y1 is 1.02x plus 100. My y2 is 50 times 1.02 to the power of x. Second graph, and if you notice by your answer choices, the smallest answer is 50. Now I can sit here and I can just scroll down until I get to 50, but there is a tip here. If you notice above window, you'll see where it says TBL set. That stands for table set. So if we hit second window, that's my table setup. I can tell my table where I want it to start. So since my smallest answer is 50, I'm going to say 50 and then go back to my table, so second graph. Now my table is going to start at 50, which just makes it easier. Now if you forget this, you can just scroll, but that's just one way to kind of save you time on the test if you're trying to figure out which one. So it's asking me what is the smallest value in which g of x exceeds f of x. So remember, g of x is my y2, f of x is my y1. So I'm trying to see where y2 is bigger than y1. So at 50, that's not happening. So I'm going to keep scrolling down. I need to see where it gets bigger. So at 59, notice I've got 160.18 and 160.83. So at this point, it's bigger. So my answer is going to be 59. Remember on this paper, if you've got any questions on anything, go ahead, circle it, put a star beside it, whatever. You can ask me tomorrow when you get into class right before the test. Keep in mind, I'm only going to be able to answer so many questions, so make sure you review this. Last thing about this paper, you were supposed to circle number 5. That one is your practice problem.